All right, so there is this fantastic redox titration animation through Iowa State that you can practice the idea of redox titrations with. I'm going to do one example for you here just so you can sort of get an idea of what we're going to do in the lab. The reaction that we're going to do in this animation is going to be the exact same reaction that we do in the lab. But there are some other reactions that you can choose from and get some practice doing redox titrations without having to mess with all the chemicals. So let's take a look here. The first thing that we want to do is select a reaction. The one that we're going to be doing in the lab is the potassium permanganate reacting with an iron solution, iron 2 solution. And as you take a look there, we've just filled our burette with the potassium permanganate solution. And then we've got our iron 2 solution sort of here on our stir plate. Now, when you perform the redox titration, again, you're looking for a distinct color change to let you know when you've gotten to that equivalence point. However, when you do this and you start adding your titrant here, you've got to be careful. You're going to look for a color change that occurs, but then fades. And once that starts to happen, you'll know you need to start adding your titrant a little bit more slowly, drop by drop. Otherwise, let's figure it to happen here. If you go too quickly, like we saw that color change there briefly, but then it went away. At this point, I would want to start adding drop-wise. Otherwise, if I keep going, I'm going to blow past the equivalence point and get that deep color change, which is too far past the equivalence point. And so just keep that in mind as you are as you're working through the lab. When you get that color change that then disappears, you want to start adding it drop by drop so you don't blow past the equivalence point. So as we take a look here, just some things that we're going to sort of make note of on the other side of our paper here, that the molarity of the KMNO4 is 0.1548 molar. We will ultimately determine the volume of that KMNO4 that we use after the titration is complete. We will use that information to ultimately determine the molarity of the iron 2 solution, and we know that we are starting with 25 milliliters or 0.02500 liters of our iron 2 solution. So let's just start adding and see if we can't figure out what the how much of our potassium permanganate we need to add until we've reached the equivalence point. So I'm just going to drop some in here. Again, I don't see much of a color change. Not much of a color change. Still no color change. No color change. No color change. I'm keep going here. Keep going. And, you know, in the lab, you should do this at sort of equal increments. Again, it's maybe a good idea to start with 1 mil increments. Still no color change. No color change. No color change. Oh, okay. So after that last addition, I had a color change that after it was mixed for a bit, then faded away. So that lets me know I need to start going drop-wise. And then I'm going to just start going one drop at a time, dropping it in, dropping like it, drop it, dropping it in, dropping it in. And this part does get a little tedious, and you're going to want to cry sometimes, but just keep going. Drop in, drop wise, drop it like it's hot. Drop in, drop in, drop in. You want to make sure that you're stirring here after each drop, dropping it in. Drop, 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 drop. Stirring, dropping, stirring, and stirring, and dropping, and dropping. Oh, stirring, and stirring. And stirring and dropping. Drop. Drop in, drop in. drop in. Yeah, this is what you're gonna be like in the lab, wanting to go insane. Dropping it in, dropping it in, drop in. Oh, perfect. Okay, so once you've got that color change and the color does not fade, again, you don't want to go too far, otherwise you will blow past the equivalence point. But as soon as you get that color change and the color stays without fading, you know that you've reached your equivalence point. And so as we take a quick look, our volume of KMNO4 that we have used is 27.8 milliliters. And so using this information plus the balanced redox reaction, we can then determine what our molarity of that iron 2 solution is. Okay, so first step, let's just use the molarity formula to determine the number of moles that was in that 27.8 milliliters of potassium permanganate that we used. We're given the concentration. We know the concentration is 0.15548 molar equals X over 0.0278. Don't forget to convert to liters there. All right, and then it's just a matter of busting out the calculator. This would not be a calculation that I would expect you to do in your head, neither would the College Board. 0.1548 times 0.0278 equals 0.00430344 moles. Let's use sig figs here. We've got 3, we've got 4. So let's 0.00 X equals 0.00430 moles of potassium permanganate, MnO4. Okay, so that's our first step. Now we've determined the number of moles of KMnO4. Our next step is then to use the balanced redox reaction to determine the number of moles of iron 2 that was in that original solution. And if we have the 0.00430 moles of the KMnO4 times a conversion factor that relates moles of that potassium permanganate to the moles of the iron 2. And as we look at our balanced chemical equation, that relationship is a 1 to 5 relationship. And so if you've got 0.00430 moles of the potassium permanganate, we just need to multiply that by 5 times 5 to give us the number of moles of the iron 2 solution. So we're going to get 0.215 moles of the iron 2 solution. And then we recognize that we had that in the 25 milliliters, 0.2500 liters. Whoa, forgot a 0. And so a quick division here, 0.02500 is going to give us a concentration of 0.861 molar iron 2 concentration. Now we can always use this amazing animation to check. Let's just type that in. 0.861. Check it. Boom, we are correct. Mathematical geniuses. Woo! Okay, you are going to do that exact same thing in the lab. It may not be the same concentration, but similar, very, very similar idea. They also provide you with a couple of different, you can either repeat that calculation or you can reset it. and choose a different redox reaction. You'll get some different sort of relationships there. But in a nutshell, that's what we're going to be doing. Get excited.